Okay, hello and welcome to a very interesting session actually on the virtual jug because this is going to be an interactive session. This is actually a preparation session for the VJug 24, and I'll explain a little bit more about that in a minute. First of all, let me introduce three people and a community. So let's start off with our speakers. So, Baruch, how are you doing, Baruch?
Hi, I'm great. Very excited to be on Virtual Jug. Thank you so much for having me, Simon and Oleg. It's a great honor. I tried to convince you to invite me for a year now, and eventually you took the risk. Hopefully you won't be disappointed. So thank you again for having me.
No worries. There were only so many excuses I could give, and then I just folded. I couldn't come out with any more. But honestly, it's our pleasure to have you.
Persistency wins.
It's our absolute pleasure to have you, and also Viktor Gamov from Hazelcast.
Hi guys. Yeah, it's kind of weird sitting on the other side because I'm usually like watching the sessions. Now I'm speaking, so a little bit. Different story, but I love it, and it's great to be here. Hi guys.
Awesome. Achievement unlocked. So the other people that we've got here is the LJC, which is the London Jug, London Java community. So hello everyone in the London Jug. Hey, there we go. So as I mentioned, this is an interactive session. So Viktor and Baruch are going to be asking many complex questions about Java 8, and we're expecting the London Jug to give those answers to us. So whoever's sitting there at the very front of the room, mostly it's going to be on you guys. In the event that you don't answer the questions successfully, it might actually fall down to Oleg and I. So please, London Java community, don't let us down. Let me quickly share my screen, Oleg, if you could make sure you can see my screen. Okay. And here we go. So this is Java 8 Puzzlers, as I mentioned. If you wanted to follow Baruch or Viktor, you can see their Twitter handles there, at Baruch, at GMAUSSA. They're very good Twitter handles to follow, actually. That's very interesting tweets. So yeah,
you skip A between G-A-M. So G-A-M, yeah, exactly.
There we go.
Couldn't you just be like Viktor with a K or something?
Yeah, that would be so much easier.
Yeah. But I'm not here to make your life easier, right? I'm here to speak about Java 8.
The sponsors of VJug are Zero Turnaround, so make sure you go and buy all their cool stuff like JRebel and XRebel. Oops. The virtual jug is you can engage with us on IRC. So for those of you who are only watching this via the VJug website, you can log on to IRC and discuss with speakers and discuss with each other. Also, please do share.
Simon, the only note I want to make here is that because we're using Hangouts on air, which buffers about 10 seconds of the stream, answering the puzzlers on IRC unfortunately won't work.
Yes, so it's mostly going to come from the LJC and us, although I'm sure we'll get some comments on IRC as well. Any feedback, do throw them our way, either to the virtual jug or to my personal Twitter account, and we can add those in from whether it's feedback about the jug itself or about this session. One other thing about the virtual jug 24, which is an online conference, which is going to be spread across 24 hours. We're going to have 24 sessions back to back, and we're going to have a jug at every single one of them, which is one of the reasons why we've got the LJC. We're happy to invite the LJC here, so we're going to test this to see how it works. Okay, so without any further ado, let me pass straight over to Baruch and Viktor. Let's go.
All right, so let's see. I need to share the slides here. And hopefully you see now about the same picture that you saw earlier, but with the title of Java 8 Puzzlers. And Oleg, can you please pin the share?
Yes, I just did that. So
now. All right. So yeah, okay. So you expected to see only the slides now. All right. Let's get started. So welcome to the Java Puzzlers. As Simon already introduced me, I'm Baruch, developer advocate with JFrog, at JBaruch on the internet, not only on Twitter. And being a developer advocate, that's what we do. We drink and we know things, right?
Hi, I'm Viktor Gamov. I work as a solutions architect at Hazelcast, and being a solution architect, this is what I do essentially. I solve the problems. And also GM, USSA at Internet, Twitter, GitHub, etc.
Okay, so the Java Puzzlers format is not new in no way. Who knows about the Java Puzzlers book?
Okay, Oleg knows.
Okay, yeah, Oleg knows. How about the London user group? Did you hear about the Java Puzzlers book? Well, anyhow, if you didn't, you should. It's a great book. This book is written by two fellows that you actually see here now on the slide, and who knows who they are? It's Josh Block and Neil Gaffner, two of the fathers of Java. And they actually, the screenshot that you see here is them performing the Java Puzzlers talk way back, I guess, almost 15 years ago. They started at Oracle World 2001, and then did it in a lot of Java ones and other conferences. And we actually stand on their shoulders, running the same format for the latest edition of Java, for Java 8. They call themselves the Typing Brothers, which is a cultural reference to those guys. And I won't even try with the London jug, because that's purely American thing. Those guys are the hosts of the car show, Tom and Ray Magliozzi. They run it starting 1977 up until today, and they are the Tappet Brothers. That's how we got the Typing Brothers. Anyhow, the rules are pretty simple. You have two entertaining guys on your screen, and that will be me and Viktor. We ask funny, hopefully funny, and hopefully puzzling questions. You think and vote. Usually, of course, all the audience will vote. This time we will only have the part who is live with us on the meeting. And then you give the answer, and it will be funny to see how you miserably fail every time. And of course
one of us will fail.
Always. And of course we have the official Twitter handles, Java 8 Puzzlers and VJug for this session. So you are more than invited to tweet along. Don't get away the answers though. And the only rule of this game, the only important rule is that you shouldn't cheat. So you're all in front of your computers, and don't be tempted to type the puzzlers into your ID or Google to find the answers. That's a test for how our animated GIFs work through the online meeting. Hopefully they are okay.
Nice. Yeah, it works.
Okay. Yeah, okay, good. So that will be your reaction on the puzzlers, hopefully. Without further ado, we just need to confirm that everything works on a latest Java 8 update. So whatever looking weird for you, this is exactly how it should be. And if you are okay with those terms, I think we should start.
Yeah.
Viktor, are you ready?
Yes. And I guess to make this like feel better, you probably want to start with first puzzler. And,
yeah. So I'll start, and I'll make it really easy for you, right?
Yep. And you will explain it all the way. Wow. Oh,
yeah. Let's start with an easy one. The first one is called Broken Egg's Tale. And Viktor, the story is very simple. We're building a grocery shopping list. We have a list, we add milk, bread, and sausages, and then I send you off to the grocery store to buy the things, and then eventually we recall that we forgot the eggs. So we will add the eggs to the list, and that will be all. And the answer, of course, the question, of course, is what will be the output?
Okay.
Do you need some options?
Yeah. Let's see what you have, but I have pretty good understanding what it should be.
Okay, so we have milk, bread, and sausage. The addition of eggs will be ignored. We have milk, bread, sausage, eggs. Don't forget eggs. That means that we will successfully add the eggs. Or we'll have milk, bread, sausage, and then concurrent modification exception because it was too late to add the eggs. Or we will have concurrent modification exception up front.
Okay, so as far as I can see here, you're using stream API to iterate over the list, and so first of all you're getting the stream, and after that you're adding something to the stream, and after that you're iterating. So my guess here, because I know the streams are actually lazy, and I don't see like how it's even puzzler. It's B. It's very obvious because stream is lazy, and only when you call for each operation, which is the terminal operation, in this case stream will be processed, and each and every element in the stream will be passed through the system out println. So my answer is B.
Nice. Yep. Okay. Nice guess.
I don't see
And,
how it's even puzzler.
Okay. Let's ask what the audience thinks about it. So, guys in London, what do you say? What will be your answer? Who thinks it will be A and X will be completely ignored?
And you guys, you can raise.
To vote, by the way, guys.
You can raise your arms, and we actually see you.
Raise your hands. We can see you, but you have to vote for some option. Okay, that's like that's your payment for being in the session, live, as opposite to all the rest. How about B? Who thinks B is the correct answer? Viktor is right, Java is right, and everything will work. Nice. That will be the half of the audience. How about C? It will break on concurrent modification exception because it's too late to add. I don't see any votes for C. How about concurrent modification? Oh, there is one. Okay. How about concurrent modification exception? Anyone for concurrent modification exception? Oleg votes for concurrent modification exception.
And I can give you a short update. The IRC is voting right now. There is C, 3 Bs, double Ds, and 1 A. So D is leading in the IRC currently.
D is leading. Okay, and that's why you vote D as well, because you have no idea and you just look at the IRC and vote as they do. Nice. How about Simon? Simon, you didn't vote.
Yeah, I did. I voted B.
He said B.
You vote B. Okay, good. And of course the correct answer is B. And I guess that might be surprising for those who voted otherwise. And who voted B for the live audience? Simon, right? Simon, can you? Why it's B? Why it's B?
For the reason, I think it's for the exact reason that Viktor said. I mean, it's lazy, so nothing will actually happen on the stream until you reach a terminal operation, which is like a collect or a for each. So it has to be.
Now you guys in the audience and Simon and Oleg, they know that I'm smart guy, so they can vote along with me. So I know the right answers.
That was we call establishing trust. Now you can trust Viktor. He just got one puzzle right. And that's 100% true. Of course, light binding works as expected, and that's a nice feature of streams that most of you probably know or know by now.
Sorry to interrupt. The slides disappeared, so currently the video is showing just a picture of you, Baruch. Can you
picture of me? First of all, picture of me is nice, but I don't know why the slides disappear. I see them and I also share them. I will try to share them again.
Yes.
I'll stop the share and I'll start the share in you. How about now?
Well, the Hangouts window is showing the slides. Let me just check the actual YouTube video.
Yeah, that works fine for me.
Yeah, let's continue until we hear otherwise again.
Yeah, the video is showing slides as well, and I will be monitoring that now consistently.
All right, so we're all set. Good. Okay. Now, Viktor, I'd like to introduce a twist to the puzzler because you did it so well.
Because it was too easy. Exactly.
It was too easy. Okay.
Now I can see Baruch's face.
What's going on?
Okay.
Now, okay.
You can just turn off.
Just give up on share.
Yeah, turn off
the share just. No, it just stopped sharing. Now it should share again. How about now?
There we go.
Okay, okay. Now I'll introduce a twist for this puzzle because it was way too easy for you. So now we're going vegan. By going vegan, of course, we will remove the sausages from the list. So we start the same with adding milk, bread, and sausages to the list, and then we remove the sausage, and then later we add the eggs. Okay, and the answers will be a milk bread sausage. The removal didn't work, and the adding of eggs didn't work. Milk bread's eggs, don't forget the eggs, which means everything worked as expected. Milk bread concurrent modification exception, or concurrent modification exception up front.
Well,
how about now, Victor?
Again, I will stick to my previous answer. So sausage would be removed, so I think B.
B. Everything will still work as expected.
Yeah.
Right. Okay, let's vote. The IRC is voting, and how about you guys? London, Simon, Oleg, cast your votes. Who thinks A is the correct answer? How about B? It will still work as expected. We build trust in Victor. Here you go. Most of the people actually trust you. This simple manipulation works. Nice. How about C? How about milk bread concurrent modification exception? We have Simon voting for that. And how about D? Just concurrent modification exception? I don't see any votes. Oleg, what IRC is saying?
IRC is saying a lot of B, like Baruch, and
Yep.
they say
like Victor.
No, it's V like Victor. B is like Baruch.
like so a couple of D's, and I see one A and two C's. So
nice.
Mostly.
Okay, so surprisingly, C is the correct answer. And I don't think anybody actually voted C, right?
I voted C.
Simon did.
Oh, Simon wrote. Okay, any ideas why, Simon?
Well, my brain said B, but I didn't believe B was the answer because I believe you were trickier than that.
Good.
I went with C, but I don't know why.
Okay, so first
it's like
of all,
going to David Copperfield show.
Yes.
Well, that's perfect. First of all, good way of thinking. Where the puzzler sessions, nothing will seem as it should be. So if you think B, don't vote B generally. And the fact that you don't know why also makes perfect sense, and that's because it's just a bug.
So essentially, this is a right thing to work. Is answers B. However,
yeah, and
in
it
Java,
will work that way if you run it on Java 8.
Yeah,
on Java 9.
Bugs are happening even in Java. So pay attention, guys. So this is a very good exception that even this like mature project like Java still might have some bugs.
And the sad thing about this particular bug is that it wasn't backported to Java 8. So it was fixed in Java 9, and if you want this behavior to work correctly, you will have to use Java 9. Right, your turn, Victor.
Okay, so let me try to. Have any of you guys seen new Netflix show, The Daredevil Season 2? Okay.
Yes, Oleg saw it.
Yeah, so the good news for everyone that Punisher actually picked up as the original show, so there will be specific to Punisher show very soon. But also I have a puzzler about Punisher. So in this puzzler, I have a executor service that will punish someone, and the result of this punishment will be written into the file. So as you can see here, 2 lines of code, and I want to ask you a question, Baruch. So what's going to happen? So how this code is going to behave? And here are my the variants, the options that you have. So A, first compiled, second will not, B, vice versa, C, Same, fine. And D, same, but both won't compile.
Well, I'll tell you what. Well, the first expression looks okay to me. The second one looks really, really ugly and strange. So for whoever knows me knows that I'm a groovy guy, and I don't like semicolons in general, and especially this thing with semicolons in the middle of the expression really look ugly and weird for me. So I would say you cannot put a semicolons in the middle of expression. So number 2 won't compile. So 1 compiles, 2 does not. I vote for A.
Okay, so A, Baruch A. Who thinks the same way as the Baruch? Okay, Oleg, and do we have a couple people in London? B, who thinks it's B? Anyone? Who thinks it's C? Everything works fine, regardless of questions of Baruch saying that there's a semicolon.
The RC is majorly for C.
Okay,
So
RC for C. D, same both, but everything won't compile.
Okay, no votes for D as well.
Okay, not much. Okay, C looks like we have a C, Baruch A, and Simon, what do you think?
I was A as well.
Okay,
A as well.
Okay, so let's see what's the correct answer.
And hey, that's right.
Okay, so let's see, maybe. But okay. So you as a groovy fanboy, you brought this up.
I told you. I
haven't seen this. You just tricked me with this slide. But who thinks it's? I still think that it's valid for Java. But your groovy argument is just like a guess.
No, my groovy argument was just for the fun of it. Does anyone actually knows why A is the correct answer? Simon? Like a guess?
No, you convinced me.
Okay, good.
So
anyone
we build
from
the trust.
London, guys?
I did, you did,
why?
so.
No one knows.
I can try.
Okay.
I don't know
Yeah, go
for
ahead.
sure. But I think it's related to the return types of the things. So if we just use an expression in a lambda, it will treat that as a runnable for some reason. And if we don't have an expression, or somehow, or maybe not, or maybe files write return something, like a length of what is written or something, and not necessarily, and it will treat that as a return value. So that you will submit a callable of that, let's say a callable of integer or something, and the return value will be whatever files write return. And in the second example, we don't have a return, so it will not compile because we would need like a callable of something.
You are vaguely in the area of the correct answer.
It would be frog, right? If we would do it on the live.
Yeah. If you would throw prizes on audience, it was the minor prize.
Yeah. Okay. So Alec was quite close, but here's the thing. So we have two interfaces, runnable and callable, and the difference between runnable and callable is that.
Sorry, again, the slides are gone.
Again.
Again.
What do you see?
Just wait. I see slides.
The video sees the incredibly attractive picture of you, Bart.
Not good.
It's because of beard.
I'll reset the sharing again. It loses sharing. I have no idea why. Let's try it again. Screen to share. How about now?
It works pretty well for me, though. I've seen.
Yeah, it works in Hangouts.
Yeah.
Now we see your video, the video view, and now we see the slides. Amazing.
Cool. Awesome.
Okay, awesome.
Okay.
So the thing is that we have two functional interfaces that fits very well in executor.submit. It can accept a runnable or it can accept callable. So difference here is that runnable returns void, and the callable returns some value. And another thing that the callable also can throw the exception. So the thing is, first one will compile because of the implicit return that we have here, because it's just a one-liner, and everything will be fine here, and the callable will be chosen here. For the second one, there is explicit return, so we need to have a return statement plus paths.get method throws IO exception. So in first case, it successfully picked up callable, and the second case, it will not be able to resolve what exactly to choose.
Let me elaborate just a little bit about it. What actually happens here is that when you do an inline lambda, like in the first statement, the return type will be automatically figured out. And since files.write very strangely returns the number of bytes written, it has a return value. And now that's why between the two candidates, the runnable and the callable, the one with the return value will be selected, and that will be the callable. Now the callable will be selected in the first expression, and everything will work fine with the exception as well, because although path.get throws IO exception, it will be successfully pumped up the stack by callable, which throws a more general exception. Now, with the second statement, we are talking about a full lambda signature with the semicolon, and that means that if the return is not stated, it is assumed to be void. Now, again, the correct option is chosen, and the correct option is runnable, because runnable returns void, so it will work, but it will fail on unhandled exception, because paths.get, as Viktor said, throws IO exception, but runnable does not declare any exceptions, so the error that we will get is the exception is not properly handled.
Yeah,
does it make sense?
Yeah, because IO exception is checked exception. You need
to
explicitly provide catch.
All right. Viktor, are you ready for another one?
Yes, I'm ready for MagicMax.
Okay, so let's vote on the important thing.
Looks like you love this movie.
Yeah. So first of all, let's vote on the important things. Who loves the old one more than the new one?
The first one.
Who loves the new one more than an old one? All right. Okay.
I still love
the new one.
Yeah, no, but new one.
Yeah. New one is cool, but old one is nice as well. And that was in the good years of Mel Gibson, so we will remember him then. Okay. So here is Max for you, MagicMax for you, Viktor. We have a system out println when I have a stream of numbers starting from -3 all the way to 3, and then I invoke max method on it. Now, instead of providing my own logic of how to select the max, I just use a function from the MathUtility class that is called conveniently max.
You don't need to explain. It's self-explanatory. It's quite easy to understand.
Of course it's easy.
Yeah.
So, here are the options for you. Go ahead and vote.
So instead of like writing our own implementation of max thing, so we're already using the library function. So in this case, it's obvious it's 3.
Okay, sounds good. Who thinks it would compile? A.
And we lost the slides.
Oh, I didn't do anything.
Very sorry
really annoying
to interrupt you like that, but.
Maybe you try to shut down your camera. In this case, it will just send the slides only from you, only slides.
I'll try to do that.
Yeah, just try to pause your camera.
Did that. Okay, how about now? What do you see?
We just need a second so the video will catch up. And we see the slides again.
Okay, sounds good. All right, so who thinks it's A? No takers for A. Yeah, a couple of hands. Good. How about B? Runtime exception. How about C? 3. Works as expected. Viktor, you lost all your followers.
No. Simon's still with me. So Simon still believes in me.
And I see a couple of hands in London as well. How about something else? Something else? Yeah, okay. What IRC is voting, Oleg?
IRC is voting AAA, B, like Baruch, 3Ds, multiple Cs.
Multiple Cs, yeah.
It's
so C is, of course, the safest choice when you have no idea.
No, D is the safest choice, I guess.
Yeah, but
because
right.
It's a puzzlers. No, I still believe it works fine. Like, you know, the code looks, you know, I don't see any problems here.
Well, of course, it's not fine, and of course, it is. What happened? Oh, my slides were nuts. What's going on?
Why it's going backwards?
I don't know why it's going backwards.
It's okay. Technology. Technology is hard.
Yeah, technology is hard. Right, of course. And the correct answer is, of course, D. It's something else. And the question is what actually happened. So I'll give you another set of options. -3, -1, 0, and something else. How about that?
Yeah, like I said, it's like we've already seen the answer, but I still have no clue why it's -1. It's crazy, you know, because you can pick up like any answer and you don't really know. I would usually, in this crazy situation, I would just simply stick to the simple one, like something else. But you know, you can explain us why this like stuff works as it is.
Okay, so as my PowerPoint poorly failed on me, and you already saw the answer is -1. Now the question is, does anybody have any idea why it's -1? Especially London guys and Oleg and Simon. Any ideas?
I have no idea why that's -1.
Oleg usually have some ideas.
Yeah.
Unfortunately,
no one knows.
Not in this case.
Yeah, not in this case. And Mel agrees with you. It doesn't make any sense. Okay, so now what actually happened is a very strange thing. Although math.max looks like a perfect function to provide to a max method, the problem is that the max method accepts a comparator, and the comparator have a very particular way of returning values.
Sorry.
Oh no. Okay, I'll explain. So in a meanwhile, so comparator, what it does, it gets two integers or two objects. And then returns -1, 0, or 1, depending on which side is bigger. Math.max works completely different way. It gets two integers, but instead it returns the bigger one. So we have the same signature of the two methods, the comparator compare to and the math.max get two integers, return integer, but they behave completely different in their logic. So what we see here is we're trying to use math.max instead of comparator, getting very funny results. So now let's see what actually happens. We provide math.max. No.
Currently I see your face in the Hangouts. So.
Yep.
This is so painful.
I think it's because of the so many people just watching online. Google cannot catch up with load.
How about now?
Now I see the slides. Thank you.
Okay, good. So what's happening here is we're calling math.max on -3 and -2, the first pair. Comparator expects to return -1 because -2 is bigger than -3, and by coincidence, math.max also returns a negative integer, and that's fine. We will select -2. The same will be with -1, but then we have a first glitch. The first glitch is when we select math.max between -1 and 0, 0 will be selected because it's bigger. But the comparator logic states that 0 means they are the same, which means we need to keep the value. And that's why -1 is kept. And this is exactly what's happening on the next one. Now we're comparing -1, the one that kept, with 1. 1 is, of course, bigger, and we will get 1 as a result, but in the comparator logic means that -1 is actually bigger because we got 1 and not -1, and that means that it will stay. And this is how it keep going and keep -1 all the way until the end.
Is I guess giveaway from this particular puzzler, you need to always check even the signatures looks right. Sometimes Java type inference might play tricks with you. So this is exactly what happens. So as Baruch explained, signatures are fitting into the lambda that expects max method, though logic of this method it's totally different. Though the signature is fine.
Right. So with lambdas we got a little bit of freedom in Java from strongly typedness. We have this type inference when we can provide a single method abstract, the single method interfaces without actually complying to the type, and Java will figure out the type themselves, and that's exactly what played here a trick on us. Without Java 8 in Java 7, we should be using comparator interface with the compare to method with a very particular logic that we know about, but now we can just throw in anything that gets to integers and return an integer back. Usually it will work until it won't, so you need to be aware of that.
So this is exception, like when you see something like quacks like a duck and behaves like a duck, but it is not the duck. So it's not duck typing. Okay, Baruch, I think it's time to upgrade your technology stack. And looks like you're stuck with some old technologies. And
yeah, I'm a Java guy.
Yeah, but you know, what about something new? Learning something new and cool. And here's the thing. So I have two maps. One map with old school technologies like Maven. I know you love Maven because I know you're running some trainings even on Maven. So
I love Maven.
Java and DB2. So pretty standard enterprise-ish and old school stack. Now,
for Simon, we should throw WebSphere in there as well.
And what I'm thinking, like we young guys like me and Alec, we prefer like very cool technology like a JavaScript and NPM as a build tool and Elasticsearch as the database. So we want to replace your stack by bringing this up. So I'll take the old school. And I want you to, replace all this technology. So I know in Java 8 there is a new method, the ReplaceAll. So here's how it works. So here's some options to you, and what do you think?
Okay, so I think I know the ReplaceAll method, and the ReplaceAll method actually receives a map. So when I want to replace one map with another, I will call ReplaceAll and will provide a map to it. So the right code that would work would be oldschool.replaceAll and proper. My answer will be D. That won't compile because it should be oldschool ReplaceAll proper.
What our audience think? Do we have A things who thinks that maps will switch?
Be stable. Did you bring your passport?
Okay, so I don't see any hands. B, so they both become the old school. Okay, C, hipster for the win. And D, the option that Baruch have chosen.
Yeah, look at me! People voting for me. That's good.
Do we have any opinions from internet, Alec? What's the IRC says?
The internet says something like 6 Ds like Dmitry, 1 B like Baruch, and 4 or 5 Cs. So it's majorly D, won't compile, and a lot of Cs. I personally think it will be A, but I I'm not sure. I guess you just twisted my brain.
Okay, that was the whole point, right? And you was close.
Okay, Oleg, and it is A, and since you are the only one who voted A across all mediums, you will have to explain it. Any ideas?
I honestly have absolutely no idea. I just...
Okay, so yeah, in this case, let me try to explain. So first of all, a couple things to remember in this particular case. So first of all, ReplaceAll doesn't take a map. There's a method called putAll, which sounds like very confusing, but ReplaceAll is actually a brand new method that's available in Java 8. And the ReplaceAll accepts a by function. We're going to talk about this in a second. Second thing to remember, map.put returns the previous value for a particular key. So when you do map.put key value, it has a return type. And so the way how it works, the method put would be used inside apply method from by function. So if I will sort of unroll all this like a syntactical sugar that brought us Java 8, we will see the following. So first of all, by function will look like this. So we're gonna pass method put from proper. So essentially we're inserting something into the proper map, but returning value would be result of this by function. So it looks like this at the very end. So Oldschool will be populated with entries for the same key from the proper, and the proper will be populated with same entries for the same key from the Oldschool.
Okay, guys.
So essentially, in this case, this map is going to be swapped.
Yeah, and talking about map swaps, who was ever asked in the Java interview to swap two maps?
Without using
intermediate
map.
Now you have a very, very sophisticated way to do it, and you really can impress your interviewer. On the other side, whoever interviews now Java guys, you can demand this answer, and until they give you this answer, they won't pass.
Yeah, because it's 2016, and the Java 8 should be, must as a knowledge for interview.
And watching this VJAX session, it's a prerequisite for any Java developer in the world.
Can we restore the slides, please?
Oh no.
But the whole explanation was covered, and it was just the last moment. I'm watching the slides closely, and IRC is super fast on giving the feedback. So
good. So we didn't miss anything. That's good. All right.
Okay. Do you have anything else to me?
Of course. As you figured out, I love the questions about max. So here is another one.
Okay.
Let's max a couple of lists. So we have a list here. It's just simple list of soft, warm, and poor. I hope someone from the audience got the reference. Who got the reference? Oleg, I guess, got the reference. What's that?
That is the song that Sheldon's mother from the Big Bang Theory was singing him when he was sick.
Of course.
But exactly. Actually, it was Penny, not Mother.
Initially, it was his mother.
It was yes. Originally,
but we remember it from Penny.
He asked Penny to sing the same song for him. So anyhow, we have a very simple list: soft, warm, poor, and then we have a kitties comparator, which takes the natural order comparator and wraps it in nulls last, just to be sure that we don't have any problems with nulls. And then we have three ways of getting the max value of this list. The first will be the old good max method from collections that gets the list and the comparator. And two more of the fancy Java 8 style max calls. One from the stream by the collect method that gets that uses max by collector, and the other is by calling a max method on the stream that gets the kitties comparator. And my answer to you, Viktor, and of course the audience, my question will be, how many lines will be the same? And the options are, all lines are the same, 2 lines are the same, all different, or 4 different.
I think everything. Yeah. What? Yeah. Number D doesn't make any sense at all.
Yeah, no, I had to come up with the 4 with number D just because we have D for all of them.
Yeah, I think everything is quite clear, and everything would be sorted as, you know, my answer is A. All lines the same.
Well,
So
okay, guys. So
logic
when
would
you vote,
be
keep in
pretty
mind
much
that statistically B is the best answer to choose because it covers most options.
and it starts with B as a Baruch.
Exactly. So who thinks Viktor is right and all lines will be the same? All right. How about B? 2 lines will be the same, right? That's a good statistical choice. How about all different?
I think they will be all different.
Nice.
I
Okay.
have no idea why.
Yeah. And I think we have a very nice distribution here between A, B, and C. What the IRC is saying?
IRC is saying 4 A's and a couple of C's and 2 B's. So
Yeah,
there is no clear winner there as well.
Okay, good. And of course, the correct answer is A. And Viktor is right, just because there is no actual puzzler there, right?
Oh.
It was quite obvious that it works as expected.
Yeah, so give me a real puzzler in this case.
So here you go. The
Okay.
only change I did here is replacing the worm with null.
Okay, so guys, just
the
a
rest is the same.
rule of thumb for you. If you want to make puzzler from anything, just add a little bit nulls, and in this case, it makes a thing more complicated. So, all right, so
Or
in this
not,
case,
right? It might
yeah,
not be
but in this case,
important.
I don't know, like how it's gonna be like a puzzler because we're dealing with the nulls at the very beginning. So we in our comparator, we're saying that nulls should be at the very end, and
Yep.
so I think it's still. I will stick to my.
We absolutely added a null safe comparator here that should protect us from any troubles. The only thing is the null will be last now and probably
Yeah.
won't be the max, right?
Yeah,
Or will
I
be
think-
the max, right?
I think in this case, I will stick to my original answer. So I think it's A.
Yep. Okay, sounds good. Who thinks all the lines still be the same and probably will be null in this case? Anyone? Viktor, even you should
No.
vote for A.
Oh yeah, I said A.
All right. Okay.
Yeah,
Good.
I said I will stick to
How
my.
about 2 lines are the same? The statistically better choice here. No takers. How about all different? Well, okay. So I got exactly 0 votes from the London Jug. Guys, you should vote. I know that you have no idea what's going on, but just guess. And if you guess twice correctly, the person sitting next to you will think of you as a very smart. So just vote. Oleg, how about IRC? What the guys over the internet
The
saying?
IRC is going mostly for B. There are
Right.
3 A's and 3 C's.
Good. But mostly for Bs. That's because they are smart guys. They have no idea they take the better statistical choice.
Slides are gone.
No. Let me try something. How about just now? Are they better?
I see slides.
We see slides, but the YouTube video doesn't show slides.
So it's not a hangout, it's somehow something with YouTube. All right, let's reload them again.
The good thing is that we saw all the voting, and just when you started going to the revealing the answer, it disappeared. So we are very lucky in this.
All right, okay, so the correct answer is C, and I don't think anyone voted C or want to explain what happened. Anyone? No. Okay, so I'll explain what happened. What happened is we used streams where we shouldn't use streams. So first of all, the easy option, the obvious option, using just collections.max with the comparator actually works as expected. And of course, we get null as the max value because we asked to pull the null last, and that's the max value.
Yeah.
So using just collections.marks works as expected. Now, when we enter the wonderful world of streams, we entering the wonderful world of optionals. Now, optional is a very nice idea of preventing null pointer exceptions. The problem
And which
is
it does.
well, the problem with optional is that the implementation on get on null is very strange. Instead of returning null, because we want to prevent null pointer exceptions, get on null throws an exception. In this case, it will throw no such element exception.
Well,
So we got rid null pointer exceptions.
they keep their promise. They will prevent you from null pointer exceptions. And
by throwing no such element exception instead. Good
exactly.
choice.
So,
Thank
guys,
you
meet you new friend. This is like a sibling brother of of null pointer exception. No such element exception. So here you go. Now you have
Okay.
it.
So when we use get on a null, and max by will return null because that's the maximum value as expected, we will get a no such element exception. Now, in the third option, when we use the method max on a stream, we will just get a null pointer exception because method max, when encounter null and in the stream, and it will encounter null in the stream because stream has null as a second element, will just throw null pointer exception. So now we have three different answers. The first one works as expected, returns null. The second will throw no such element exception because get from optional returns null, and the third will fail with null pointer exception because get from stream encounters null and throws null pointer exception. Fun.
This is what we call consistency in Java. And
Yes.
remember, just throw in multiple nulls in this case, and we'll make every piece of code a puzzler. All right, so we already talked a little bit about duck typing and ducks. So let's talk about some mutants here, and some very very rare animals like I don't know what's the word you use in
Dogcat.
English?
The name is Dogcat.
Dogcat. Okay.
Yes.
Dogcat. So we have two interfaces. This is very it's a very interesting thing. So we have two interfaces, and as we learn in
The
computer
slides are
science.
gone.
All right.
Okay, so while I'm talking, I still see the slides. So I continue to talk. So now I lost slides as well. As we learn in the computer science. In computer science courses or like object-oriented courses, interfaces are essentially create some behavior. So we have interface cat and interface dog that creating behavior that plus some default methods. One of the cats can do meow, and the dogs can bark. Now we want to have ability for some reasons to we can implement two interfaces, right? So
Slides.
it's not a problem for us to implement multiple interfaces.
And now with default methods, we will inherit both behaviors.
It would be cool, right? So, and it would be nice to have it. So, and here's a couple of things that I want to show you, like in the way how I can use this both interfaces.
Don't go anywhere, please. We lost the slides again.
Okay. Now it becomes more frequent, right?
Yeah.
As the time passes.
And it was a bit frustrating, but hopefully.
Okay, so here's a couple options how we can do. You probably know that in Java 8 we can use type intersections, so we can use ampersand not only for like purpose of ampersand and combine, but also we can use it to combine two types. And here's a couple options that I think should help us to to write this method test to make the dog and cat this Newton
Just
guy.
to notice one thing right here is that we cannot use the dogcat class that we declared because it is local to the main method. So that's the reason why we cannot cast to dogcat, and instead we need to use the intersection type.
Of course.
So from those options, what I see here are valid options of using the conjunction of interfaces. The first one is just using dog and cat. The second one is if I cannot just use dog and cat in casting, maybe I can use it as a generic. So instead, I will use it in the consumer signature extends dog and cat. The third one is I won't even comment, and D means that probably we want to do something that shouldn't be done at all and cannot be done in Java.
Or it's prohibited by or world conventions to, you know.
Yeah, UN some UN convention probably prohibits it. So A won't work. I know for sure that you cannot cast to an intersection of types. But second should work because that's exactly the new thing of Java 8. Now you can use the conjunction of types in generic types. So my vote will be B.
Okay, so who thinks it A, and it still might work for some people?
Guys in London, you should vote. Oh, here we go. Thank you.
Wait. You're pushing people to wrong answers, maybe.
No, I push people to vote. I don't.
Okay.
You know,
who thinks it's a B for Baruch? Who thinks it's B is the right answer?
Can we restart the slides again, please?
Yes.
And while we are waiting for that, not sure. I can say that I am extremely confused by this puzzle.
That's
and this is what we hear from the person who runs the monads presentation.
Yeah, exactly. Oleg, if you are confused, we are all in deep shit. So who votes for B? No votes for B at all.
Who thinks it's C?
How about C? Yay! I think a couple of people considering voting. Oh, then they actually did. Okay, thank you very much.
And
how about no way in the world this shit should or can be done?
That's a tempting answer.
Yeah,
it is a tempting answer. How about the internets, Oleg?
The internets, there is somebody voting really hard for B, like multiple answers. That person, I think, is super sure that this should be B. And the rest
might be me.
It might be you, but the rest of the crowd in the RC is also like divided between different. I see at least one C, one A. I see a D, like you are very unhealthy people.
Yes, we are.
But mostly I think it's B, the RCs.
Nice. Okay. So, the C's guys are actually right.
Okay, so let me explain how it works. Or my best friend from past will help me to understand this, and this is Bill Gates, and this is how he explains how it works. All right, so this is another piece of magic that Java type inference in Java 8 does for us. So first of all, this syntax intersection of types only available in generics. Yeah, so the Baruch was right, but this is not the place where he needs to put it on the B, but in the C it works pretty much in this way. So optional of will return another optional with the type that would be inferred from the previous call. In this case,
the only place conjunction works is in type inference actually.
Yeah.
And that means that that's just an example of type inference. We can use we could use any other example of type inference and then do the conjunction. But that's the only place where this crazy shit can be done. Otherwise, it's just cannot be done.
Yeah. So optional off is just like a fancy way to wrap this call. So the type inference will do this like a trick for us, and it will pass a type for x variable in method if present, which pretty much also doesn't do anything for logic of this, except just passing this mutated type in the runtime into this lambda.
all the rest is just code to make it compile. The only thing that we wanted to invoke here is some kind of a type inference, because that's the only place when we can do it.
Yeah.
So but it's kind of confusing, and that's the second puzzler that bites us for type reference in Java 8. The first one, if you remember, was casting a MathUtMax to a comparator. And since type inference it's so new and so foreign and so unnatural in Java, it brings a lot of very puzzling behavior into Java. And the question is, should it be that way? Will we as Java developers will adjust and will embrace this dynamicity in types in Java, or it's just something so foreign for Java that it shouldn't be added in the first place? And that's a question that we will have to figure out. Now, Victor, I have a puzzle for you. Now, this one is a true story, and this is me and Victor during the DevRel conference in San Francisco, calling the United Airlines customer support. You remember that?
Yes, and actually this is very good puzzler, I guess, because it helps Oleg to properly spell the letters. So instead of saying B for Baruch, he would know there is a NATO notation for spelling the words, and we know it's a beta, right? So instead of A,
okay.
A it's alpha.
So
B
the story
beta.
goes like beta. So the story goes, we called the customer support and we tried really hard to make us hear and understand us. It was a very noisy environment. So we started with just saying hello. And then we figured out that that's not enough, so we made all the calls uppercase, like we were shouting, so we shouted hello, but it still wasn't clear enough for the other side, so we went to the NATO phonetical notation of letters, and we actually spelled the letters one by one. Hotel, Echo, Lima, Lima, Oscar, meaning hello for the other side to hear us. And the question for you guys is, what will be the output of this Java snippet, which is exactly the same. So the first will be we print it twice. So here are the two options: Hotel Echo Lima Lima Oscar twice, hello Hotel Echo Lima Lima Oscar, Hotel Echo Lima Lima Oscar hello, or hello hello. Those are the options. Victor, what do you say?
Yeah, I think it's option one. Hotel Echo Lima Lima Oscar. Hotel Echo Lima Lima Oscar.
Why would you think that?
I don't know, because it's the puzzlers. I kind of already don't know what to choose. I just pick up the first one. It just looks nice. I don't know.
Well, the actual difference is that we use lambda in both ways. The supplier accepts lambda. The first one we refer to an existing method to uppercase, and the other is we wrap the same method to uppercase into a lambda call, right?
Yeah.
That's the difference.
The only thing
and you
which
say
STR
one can
will
difference.
take.
Both of them will work in the same way. All right. How about our audience? Who thinks it will work the same way in both cases? How about, okay, thank you. How about option number 2, which is it will print hello and then Hotel Echo Lima Oscar? Yes, couple of hands for 2. How about number 3? And Oleg votes for 3. And how about 4? It will call hello, hello twice. No takers on this one. What IRC is saying, Oleg?
RC switched to... Oh, we switched to numbers, and RC switched to numbers as well. That was very puzzling for me at the moment. So let me just gather. It's 3223143143. Several ones, a couple of 2s, with a mix of random 4s. So I think
good.
I think one is leading currently, I think.
Okay, vote. Did you vote, Oleg?
I voted 3, number 3.
3. All right. So since the correct answer is number 2, I won't try to force you to give me the explanation why, and instead I will explain why.
The slides are gone. The slides are gone.
Okay. All right. Did you see the nice lady hanging the telephone?
I saw that in the Hangouts, but I didn't catch if the actual YouTube video caught that.
Okay, now let's replay it because it's a very important slide.
Yeah, I feel like doing that with my microphone right now, so.
Okay, good. All right, so let's talk about what actually happened. Although the 2 calls are, as I mentioned, calling to lambdas, the first one refers to an instance method, the uppercase. The instance method reference actually tied to an actual instance. And since string is immutable, it will be hello even after the change. The other option, then the S2, is a lambda that is evaluated in runtime, and it refers to a local variable that points to an object. And when this pointer is changing to hello echo lima lima Oscar, the lambda that will be called in the last line will in runtime evaluate the contents of the string and will take the updated string instead of the original one. And that's why the first will be the same. It is instance method of an instance hello, and the other is a runtime evaluated lambda that will take whatever it is there by that time.
So as you can see, like many things, they look very similar, and from the perspective of the S1, S2, they look quite similar, but sometimes they behave totally differently. So this is why the answer is number 2. All right. So let me introduce you to my friends. It's a Chuck. You probably know them. It's favorite characters from childhood. All right. I have a slide. I have Chuck and Arnie. Okay. So here's the thing. So I have list of the characters, and I want to remove one of them. I want to remove Chuck.
Good luck with that, my friend.
Yeah, I think you guys already wishing me good luck and stuff, and many of you probably anticipate what's gonna happen. Most likely, it's gonna happen like a kick to my face. However, what do you, Baruch, think? What's gonna happen here?
Well, I know exactly what's going to happen here. You will get a concurrent modification exception because you generally cannot remove a list while object from a list while iterating on that, and especially not Chuck.
Well, okay. So who thinks it's one concurrent modification exception?
Yay! Good job, guys. Trust in Chuck.
Who thinks it's 2 or 8 out of bound exception?
It's just some random exception that you throw in. How about null pointer exception? Now, null pointer exception is always a solid choice, guys. We are in Java. Null pointer exception can always happen. It's solid. How about null pointer exception? No takers. Ah, here we go. Yeah, come on, guys. I thought almost 2. 1.5. Vote for null pointer exception. How about no exceptions? Everything works. You can just kick Chuck out of random list and it will just work. well guided out, seriously.
Okay.
I cannot even imagine why anyone will be so naive to think he can kick Chuck out of Beast. And the correct answer, of course, is number 3, null pointer exception,
So yeah,
which
Baruch,
I personally very surprised about it.
So and
Also,
Baruch actually provided you a pointer about very, very, very common exception. Okay, so let's try to
Oleg,
figure
we
out.
didn't ask how the RC feels about the options. What did they say?
The RC said predominantly ones. There was 1-3 by a person named a sip of Java. Don't know who that is, but congrats, a sip of Java. On this one, there were a couple of 2s, multiple 4s. We are trusting people here.
So what we saw here is Chuck Norris being defeated by Java 8.
Yeah, you guys need to remember this because this has not happened very often. So let me actually try to explain why. So here's the for each loop will be expanded to special way how this stuff is gonna happen with streams, and the special type of iterator called splitterator will be used to iterate over. So the difference between how it usually works with list, it's actually instead of like a shrinking list down when you're removing, it's actually putting null into the actual result. So when you're removing this, it's not actually removing; it's just writing null. So I guess it was done for speed because changing the size of the array might cost. So actually, the null pointer exception, you will be very surprised, it happens on method equals. So remember the time when the people saying that you need to use. Can I see the next line? So the people saying like you need to use a string and after that do equals. So this is one of the cases you can actually prevent this from like just switching the Chuck equals and the actual element. So null pointer exception happens over here. Or
and the only reason we got it wrong, me and Chuck, is that it didn't get to the concurrent modification exception because the concurrent modification exception is run last, and we fall with null pointer exception before we actually got a chance to get to the modification count comparison. And that's the reason why. And of course,
the safe way is to do.
Both of us, me and Chuck, are not very pleased with Java 8 in this regard.
True, and we need to restart the slides.
Okay.
So everybody can enjoy Chuck not being very impressed with Java 8.
Okay.
So here's another like takeaway for you guys. In Java 8, there were new the streams actually introduced new way how the thing works. And when you watch the Brian Goetz talking about streams, that streams provide you some external iteration, but there is still an internal data structure that related to this. And you need to understand how it works to prevent a certain situation in this particular case. Yeah, Baruch, I see your very interesting and amusing picture. What do you want to tell me?
That will be, of course, our next puzzler, which is called RTFM or else.
Okay.
And me being a very big opponent of reading the documentation is actually the right person to ask you that.
Okay.
So we have two printlets here. And both of them supposed to print exactly the same, and that's the string RTFM. The first will take an optional out of RTFM and then call or else get with null, and the second will take an empty optional, will add a null to that, and then we'll say if it's null, else print RTFM. So in the first case, RTFM will be printed because it's not null. In the second case, the RTFM will be printed because it is null.
Okay.
That's the logic. And the options are RTFM, RTFM, RTFM null pointer exception, null pointer exception, null pointer exception, and null pointer exception RTFM. I think I covered all the possible options here.
I guess just to be very popular with popular exceptions, I'll go with C, null pointer exception, null pointer exception.
Yes, yes, and as we already mentioned, and then we actually saw it, null pointer exception is a very solid choice in Java puzzlers.
Yeah,
it can always happen, and we can maximize it by going to 2 null pointer exceptions. What can be better than that? Optional and null pointer exceptions are best friends. Okay, and we are back to characters from numbers. Who thinks it's A, RTFM, RTFM? Everything works as expected. By now, I don't see a lot of takers. We've been doing it for an hour now.
I don't see a lot of people because it looks like London guys are leaving.
Yeah, no, it's our fault. We run past an hour, so people have commitments and have to go. I hope the RC are more persistent with us. And doing this puzzler for an hour now, no one actually believes it works as expected. So no takers on A. How about B? RTFM null pointer exception? All right, a lot of hands for B. That's good. How about C? Null pointer exception, null pointer exception. As we mentioned, solid choice for Java. Oleg, Viktor, both are takers. And D, null pointer exception, RTFM? Not so much. Oleg, what do we see over the internet?
Over the internet, reporting from the RC chat, we have multiple Bs, like Baruch. The RC agrees that it should be RTFM null pointer exception. We have one A and one D.
All right, okay. So actually, both the guys in London and the RC are right. And B is the correct answer, which actually a good answer, because that's exactly how it's supposed to work. So or else get works as expected and returns an object, so it will return RTFM, but map.null throws null pointer exception when we provide a null to it, so we will never get to this wonderful all else that was supposed to provide us with RTFM string, because we fell on null pointer exception before that. So well done, guys. Well done, London. Well done, IRC. That was apparently an easy one, and if you read the manual and the documentation, you actually know that. So good job. And with this positive note, I would like to give a couple of minutes to conclusions, and then you will be off the hook with us. So the conclusions are very simple. But Spider-Man. And what I mean by Spider-Man, I mean, of course, the phrase with the great power. Yeah, just Spider-Man. That's the conclusion. With great power comes great responsibility, and that's exactly what we have now in Java. We got much more power with Java aids, with lambdas, with streams, with optionals, but it also comes with more ways to shoot ourselves in the foot. So we need to pay more attention now to what we are doing. First of all, now there are more ways to write very strange and bizarre code. Don't be tempted to do that. Write a readable code.
If you remember, if you remember example with mutants, for instance.
Exactly. Don't do that.
You have a class like static class, and after that you're writing some bunch of the code that doesn't make any sense for anyone except you. So try to write readable code. However, if you're very tempted to write very unreadable code, write a comment. So if you feel that so you really for simplicity or concise syntax or whatever you're thinking, always tell your colleague. Do not make them suffer from poisoning of Java puzzler.
Of course, of course. We saw an example of a bug today, just to make you aware of that there are bugs in Java. They are much rarer than you would want to think, and when you write something wrong and it doesn't compile or it doesn't work as expected, don't jump to a conclusion that it's a bug in Java. Usually it's not, but there are. So eventually, if you end up with a positive conclusion that you did everything right, it might be actually a bug. Another thing, all of our puzzlers weren't puzzlers at all if we would show you an IntelliJ IDEA screen or an Eclipse screen with this code, because all the major IDEs and the other study code analysis tools will spot them 100% correctly and will know that you are doing something wrong, including the even obscure ones like using the math.max method as a comparator, because IntelliJ will tell you, dude, this is probably not what you intended. So just writing the code in a good IDE solves most of the puzzlers here as well.
Do not write the code in Notepad and PowerPoint.
Read the manual, of course, and
don't worry.
Many tricks and many things that many puzzlers that we showed
wait
today.
a second, Victor. Oleg, the slides disappeared?
Yes. Just before you showed the RTFM one more time.
Many puzzlers that we encounter today, you might avoid them by simply reading documentation and understand the contract. So this is why we have a puzzler at the very end, where you understand that everything that we did is actually written. And sometimes if you're not sure how the new things works, like optional, for instance here, you
should absolutely read the documentation. Yes. And the other thing is, don't jump to lambdas and streams just because you can and you know. And here the classical example will be the determining the max value. The collections have a great max method that accepts a comparator and figures out the max value.
By the way, both puzzlers which are related to max values,
yes.
one way or another, they work with collection.
Yes, and not using lambdas and streams there would simply lambdas streams would be the logic and actually provides you with the right behavior. So use the lambdas and streams when you need to. Don't use them when you don't need them, right? So we just got started. And we're already working on a second season of the Java Puzzlers, which probably will include also Java 9 Puzzlers as well. So if you personally, both in London on RC, Oleg, Simon, encounter some interesting behavior, please send those puzzlers to us at puzzlers@jfrog.com. And the @ disappeared, but it's there. And we will send you some T-shirts and if your puzzlers got accepted, and generally will be much grateful. Give you a credit during the next season of puzzlers as well, of course.
We already started working on Java puzzlers for Java 9, so stay tuned.
If you liked it, go ahead and praise us on Twitter and in the feedback form of the virtual jug. Java 8 Puzzlers is our hashtag. VJug is the hashtag of virtual jug. @Gamusa is Viktor on Twitter. @JBaruch is me on Twitter. And if you didn't like it, your feedback is also very, very important to us.
Yep.
Do you see the slides? That was a joke right there.
So the dev null thing?
Yeah, when there's joke and people get it, you don't actually, you don't need to repeat it to explain. But dev null, it's special place where you can send this request, etc.
I hope it's just that people got tired, and because it is a good joke.
It is a great joke. So thanks amazingly for the session. It was great fun. I am super tired thinking about this. The IRC was always buzzing and answering and voting. We had one question, so if you guys have a second. So a sip of Java.
We have all the time in the world.
That person that single-handedly got some puzzle right for some reason. So he asks, it says, great session. Any of the speakers, what would be the best static code analyzer for Java 8? And he clarifies that he or she, like, they actually use Eclipse as the IDE of choice. So is it IntelliJ IDEA or is it something like Findbugs? Do you have any comments?
Yes, so I guess I can answer that twofolds. First of all, IntelliJ IDEA traditionally does a great job in being awesome static code analysis tool, and that's a great IDE to cover most of the things that you can fall on. Although probably it makes sense to run an offline static code analysis, which will run as part of your build. And here we have great news for you as well. There is a new project that is called Handbugs, which is based on a very well-known project.
Find bugs.
What the name? Bugs?
No. It's
Findbugs, right?
It's superseded
Findbugs.
Yeah, Findbugs.
Yeah, so the Findbugs is the old one. It's pretty much not up to speed with Java 8 and with Java 9. And there is a fork of Findbugs that is called Handbugs. I think it's a rewrite from scratch, but it follows the same philosophy. So you are more than welcome to use it, give it a try. It's now beta, more rules getting added every day. It's a very vivid project by one of the committers of most of the puzzlers in this presentation, Tagir Valiev, a Russian guy from Novosibirsk in Siberia. They don't have much to do, so they learn and then they work on awesome projects like Handbugs. Give it a try. That will be my two recommendations: IntelliJ IDEA with Handbugs as part of your build process.
And if you want to see like another plug, but probably I can follow up here. If you want to see some other awesome things that you can do with streams, the project called StreamX is for the same author. You can take a look and you will see how you can abuse the streams all the way. There's not abuse, sorry. It's more like a more fluent API for writing streams. It's pretty cool. Check this out.
Okay, sounds good.
Yeah, that was great. I think that should satisfy the most attentive listener. So thank you, guys. I have no words to describe how amazing the session felt for me, having this first-class seat, and I hope everyone else was as thrilled to follow the session. And even despite all the technical minor things with slides, I think we managed to blow the minds of many people, and hopefully we'll do that when they will watch the recording and again and again and again. So the video of this session will be available on YouTube just in a couple of seconds. I just want to encourage anyone who is watching to connect with the speakers on social media and find them and ask them questions. They have so much expertise and such a vast network that even if they cannot answer a question, they will point you.
I'm just melting from all your flattened comments. So thank you so much for having us. You see, my cheeks are pink right now.
Oh, let me switch to you for a second, since we were still stuck on the Baruch screen, so we watched whole this session was the final note, just looking at the screen. Sorry about that. Let me switch it off. So anyway, it was a great session. I enjoyed that. If you enjoyed that, go tweet about this. Use the Java 8 Puzzler hashtag.
I lost audio. Was it just me?
No.
I cannot hear you.
We can hear you.
Okay, good.
Yes, it's just me. Let me try to.
So basically, follow us. Follow the virtual Jack. Then just go and register for the virtual Jack 24, which is the conference, the full day of this awesomeness. And I think we get some feedback, and I think this is the right time to say thank you for the viewers. Thank you to the speakers once again. We're off. This was a great evening. Thank you.